Hi guys, good afternoon. I guess I have still people connecting here. I'm gonna start like 30 seconds. We really have to start right on time because we are packed. We have planned here three demos, and at least two of them take a little longer. One of them takes quite longer. I'm gonna start it right in the beginning. I give an initial introduction, then I can move to the demo itself, or at least have it started so you can review it by the end of the demo. And to be very concise and precise and doing all that in only 1 hour, let's get started then. So I'm gonna show my screen here. Please let me know if you can see it. Here we go. All right. I guess you can see my screen, right? Once again, good afternoon. Nice to meet you. My name is Luis Barbosa. I'm from Webira. I'm the head for Americas. We are talking today about machine learning, artificial intelligence in the context of the Google Cloud Platform. We, Webira, are partners of Google and AWS. So of course, all the content here is going to be focused on the Google platform. But of course, there are similarities when you're talking with different cloud vendors, either Google or Amazon. Anyhow, we normally work with those two platforms, right? Talk a little bit about myself. I started my career back at the first wave of startups back at late 90s. Then I moved to a more corporate environment on the financial market. Then I spent about 10 years on the telecom segment, on the telecom industry. After that, I moved to the digital marketing space, working with a partner that worked with Facebook and Google when I was invited to work within Google Ads team here in Brazil. During that period, I was working closely with the Google Cloud folks, and that's when I met Webira and moved to Webira. And since that, I've tried to get an expertise on the cloud environment, especially artificial intelligence, machine learning, and so on. Actually, I'm doing a PhD degree right now on artificial intelligence, and I got a couple of certifications, both for Google and AWS, right? For Google, I'm certified as data science, data engineering, and on AWS, I'm certified as architect professional. And talk a little bit about Webira. We have two main pillars of work. The first one, it's what you call revenue protection, in which we comprise managed service, information security, and hosting. The main idea here is to keep operational all the infrastructure, IT infrastructure of the customer, of course, within cloud, and the customer don't have to worry about its infrastructures. They can simply outsource with us, and we can manage all of it for them. And the second pillar is what we call revenue creation, in which we have application development, but more strongly, we are experts in DevOps, which in that sense, we can continue growing and evolving the environment of the customer with a strong use of automation and pipelines of continuous delivery, continuous integration. We can definitely have a whole talk about this topic in a different session, right? And who is Google? I believe everybody knows who Google is. Behind this very simple interface with a very simple logo and a simple query tool here, behind of it, there is a very complex infrastructure, IT infrastructure. In fact, Google had to develop their own IT infrastructure in order to be able to provide that worldwide service that everybody in the world currently use. And in that sense, that IT infrastructure, IT technology that they've developed, at some point they decided to sell. It's a single product or a different business unit within Google. That's exactly what it is, GCP, Google Cloud Platform. That's the technology proprietary technology that Google developed in order to support their own products. And now they're selling to their customers. What's the idea behind cloud computing? The first thing is it's considering not an investment, not a capex expend, but an opex spend. So you pay as you go. It's something more similar to electrical energy. So once you use it, you are paying. Once you stop to use it, you don't have to pay anything else. There is another concept involved, which is elasticity. So you pay and use as much as you need. You don't have to have upfront commitment or upfront investment infrastructure. If you have peaks of usage, you allocate more resource and more infrastructure for that peaks. And once you don't have that additional demands, you simply scale back and pay. The third property here is resource pooling. The idea is the average cost of unit decrease over time, and it's not a theory. It's a real thing, either for Google, for AWS. On average, the cost of most products decreases as a consequence of scale of usage. Then you have access for network. So as everything is virtualized, and you don't, most of the cases don't have the sense of the physical geography, localization of the resource. Everything must be accessed through the network. And in that sense, a main concern within cloud is security, right? Every single talk or webinar or whatever that's going to have about cloud, going to have a small topic in terms of security. We here are going to talk about security a little bit. And lastly, those services are always on demand. Doesn't exist a real person when a customer requires a new server or a new database or new whatever. There isn't a physical person that's going to bring that server up, the database up. Everything's automated, and you simply with a couple of clicks can require and can have it up and running a new server, new database, or any resource that you want. That's a picture of the Google Cloud. Actually, it's a little bit unupdated. They just released, for instance, a new region here on Chile. Those colored dots here or drops are what they call regions. And within a region, they have availability zones. You can consider availability zone more or less like a data center. It's not actual data center because it could be more than one building within a single zone. So here, for instance, São Paulo, 3 zones: East US or Central US or Western US. For instance, North Virginia, similar. They have three available zones. 3 zones. So each zone roughly is a data center, and each data center of those are separated in at least 100 miles. So in case of a contingency, a problem, and if by any chance they lost a whole zone, which is very unlikely, have 2 others within the same range to cover. So that's a structure in US, in South America. In Europe, we have different countries with different zones, South Asia and Australia. And those gray dots here is what they call edge borders. So for instance, if you're in Mexico, you want to access a resource here in East US, you don't have to navigate through different hops within internet. Everything's connected through a proprietary network from Google. So everything is proprietary, is not outsourced anyhow. And from Mexico to East US, you have 1 or 2 hops only, not hundreds of hops to public internet. So it's the latency and the response of the service are very quick, right? And as I mentioned, all these blue lines here are network proprietary connections. Here actually you can see a submarine cable covered with Kevlar that actually have been attacked by a shark here, and nothing happened at all. And here you can see an example of a availability zone, a zone. So in this case here, they have 2 data center building. Since 2007, they are carbon free. All the energy are produced environmental friendly. As I mentioned, security is always a piece here. So it starts in all levels, since the hardware level. This is an example of a CPU from Google, and the CPU is embedded, is proprietary, the CPU, the hardware, and within the CPU is already embedded some features, security features, and goes up to the computer hacks and the data center, the physical access, and so on. So up at some level, the security responsibility is up to Google, and at the level of the application and permission grant and so on, it's responsibility of the customer. So it's a divided responsibility, but it starts since the hardware up to the users of the end user. So there's a complete control in terms of security. In terms of product and service, there is hundreds and hundreds of services. I'm summarize here the 4 main pillars and some of the main service that's involved within Google. In terms of computing, they have computing engine, which are servers, Kubernetes, which are containers. We have a separate webinars talking about Kubernetes and containers, very interesting. In terms of storage, we have object storage and different kind of databases. We also have big data processing, and the main database for big data is called BigQuery. We're gonna have one of the 3 demos that I mentioned is actually based on BigQuery. And lastly, the machine learning segment, which is the main focus here for this talk today, in which you have the machine learning engine, where it's possible to build our artificial intelligence models on our own. We're gonna do it right here on the demo, and also have pre-trained APIs that can be used. You don't have to build the model on your own. The models are already built by Google. You simply use it. If you want to use natural language processing or visual APIs for image recognition, for instance, or speech recognition or translation, there is already a strong Google model that's actually embedded within their products that you can simply use, right? And what machine learning is, for most people, for lane term, people think there's a huge volume of data that's passed through a mathematical process that's in the end produce a magical result. So it's a big black hole here that you don't know, but actually it's more or less like this. There is a very strong effort in terms of collecting data through different sources, then trying to organize and structure that data. After that, creating a model that represents or can do analysis within those data. And it's estimated that about 70% is spent on that end effort in terms of collection, organize data. And this is a cyclical process. You collect, organize data, create a model, test it, experiment, and if it doesn't work, we iterate and repeat the process, keep repeating up to the point that you have a strong model that you can use in production. That's the magical result that's expected. So as you have that workout to do, let's start our first demo. I'm gonna use the AutoML, which the automated model that Google's provide. Gonna generate our data, feed the data to him, and let's see what kind of model he can produce. That's one of the demos. The other demo gonna create a whole new model from scratch. And the last one, and the smaller demo gonna do, is the simplest usage of BigQuery. So let's do this. The idea here, I wanted to try to correlate the information in terms of currency exchange and stock market. I could do it, for instance, the relation between US dollar and euro in relation to the Deutsche stock market. It's going to be interesting, but the variation is much smaller, which are more stable market. Probably going to be more interesting if you consider underdeveloped countries, underdeveloped market in comparison to more mature markets. So if you compare, for instance, Brazilian real here in Brazil against the dollar in comparison to the stock market in Brazil, we're going to see huge variations, even without considering the coronavirus lower that you have recently. You can analyze, in fact, let's analyze the last 5 years, disregarding the initial period of this year, the 2020. So let's do this. So I'm going to create a spreadsheet here with data, and I don't know if you know that feature from Google Sheets. Very interesting. It's Google Finance. can query stock information. So I can query here, for instance, US dollar against Brazilian real from January 2015 up to January 2020. So I'm missing here the first semester of this year. And I'm missing one detail here. I wanted the closing price. Right. So here it is. So you have here the code varying for the last 5 years. I can also query the stock codes. So the stock codes in Brazil, the stock market, it's called Bovespa. The ticker is IBOV. So I have here IBOV for the last 5 years. Let me try to correlate the exact dates, because the dates are different here. Some dates that are holidays, we don't operate the stock market, but you have the exchange rate for that. So I have to try to correlate that more closely. I guess here the date without the time, and the same here. We have the date without the time, and can do a VLOOKUP here for cross-reference those. So I want to VLOOKUP for this date. I want to check what was the dollar rate, which is third column, and the last parameter here is false. Right. So here you have it. So here is USD, and here gonna be and as they are in different scales, so the stock market in Brazil in points, and currently the points is it's close to, let's see the values. We are close to 100,000 points, and the exchange, it's probably over R$5 for each dollar, 5.33. So as two very different scale, we can divide that for 1,000. So you can have more or less same scale. It can make easier for some algorithms in terms of machine learning. So let's do that value divided by 1,000. Right, let me move those to a different clean sheet here. And that's the final one. I'm going to export it as CSV, and let's load it within Google Cloud Platform. So within Google Cloud Platform, you're going to use the storage service to store that information. So we're going to create a bucket. The name is a little bit odd, but it's where a repository for different files, different objects. I can use here, for instance, Webera, machine learning. I'm going to have it in US region. Going to be the standard. The standard varies the price that they charge for the data. The access control going to be fine-grained, so I can give specific permission for each file. And lastly, all the files within Google are storage encrypted. So in terms of security, again, there is a lot of constraints and concern. So it's not possible to save files that are not encrypted, either stored or on transit. If I am transferring any file or information, it's always encrypted. The question here is if Google gonna manage the keys, the encryption key for us, or if we're gonna provide the security keys. I'm gonna let Google manage it for me. So I'm creating the bucket. Within that bucket, I'm gonna upload my CSV here. Here it is. For the first demo, I don't need to expose that externally. I could simply use it as it is, but the last demo they're gonna use creating the the module by our own from scratch. We're gonna have to use it or to access externally. So I'm gonna already do that. I'm gonna add permission here and add permission for everybody. So anyone on the internet, all users can read it. Once I've done that, they created that link here. I'm gonna save that link. And I have it here. And then let's start our process that takes a lot of time. That's the process to AutoML. So AutoML, they're gonna simply feed the data, and Google AutoML feature gonna try different models and provide us the model that has the best results, predicting those results. So here in the artificial intelligence section, you're gonna use AutoML tables. Let's register our data set. New data set. I can leave whatever name. I could put a better name. I can import the data from different sources. I'm going to import it from this CSV file on cloud storage, as I already put. Let's find it. We'll put it here. WebML above. That's the file that you used. I'll have to create a different bucket. I guess I put it in a different region, this bucket in a different region. Let me recreate the bucket very quickly. Storage. Artificial intelligence. The region is going to be Central US, right? All the standard parameters, right? Then upload the file again and make it public. Right. Okay, let me save my little link here. Here it is. All right. Let's see now if it recognizes the right region. So that's the second bucket. I guess you get it. Let's import. So here's the first demo, which take a while. We're going to use, as I mentioned, the AutoML. AutoML, you simply feed the data to Google, and Google going to create different models and try to find out the best performing module that they can do automatically. I'm going to feed the data, let him process it. It's going to take about 40 minutes. So, and by the end of the presentation, coming back to finalize that demo. The second demo, we're going to create a model from the scratch. Of course, I have a sample code here already typed. I won't type it a bunch of code here, but you can follow up block by block, step by step, what you are doing in terms of programming. You don't have to be a programmer to understand all the details, just to have a general idea of how is it working. And lastly, which actually going to be the first actual demo, we're going to go from the beginning to end, going to be a simple, small exploration for BigQuery. BigQuery, it's very similar to a regular database, a relational database that if you are used to use, in which you can do queries and extract information from tables and correlate information from different tables. BigQuery looks like very similar to a regular SQL database, but actually internally they structure very different. He's focused on performing as a data warehouse, not a transactional database. So it shouldn't be the database that's going to be used by a CRM system and create orders, new records, and so on. Should be something to be fed from the transactional database and create a separate repository, a warehouse, a data lake, in which you can analyze from report and analysis to bring insights, right? So he's very, very powerful to process or to read a large amount of data. You can read billions of records in a matter of seconds. You can update and insert information, but it's not as fast to insert, update information. He's more fast and performer for read information, right? So here it is. Our first demo loaded already our data, and the idea here is, as I mentioned, it's of course like almost a play here or something like just to give an idea. It's not very serious. There is a different parameters, information if you want to forecast exchange rate and stock market. If it were that simple, probably all the stock markets were broke by now. But the idea here is that I wanted to try to predict the correlation between US dollar and Brazilian reais based on the stock market. So once I have the information where the stock market is going today, or going to close today, I have an idea what to be the final value of the currency here. All right. So I mentioned here the target column, what you call label, or this label that's the information that I want to predict. That's the target column. In the other columns here, we'll have an additional column, which is the stock ticker for Bovespa, IBOV. That's what we call features, that the information, the variables that I'm going to use to predict the target column or the label. So here we're going to train the model, and Google recommends here up to 100,000 rows. It take about 1 up to 3 hours to process. The minimum that they use as a reference to process is 1 hour. 1 hour, let me put 1 hour here, and they're gonna charge based on the amount of time that they use it to train. The feature, I could select different columns. Here I only have one, so I have this feature, Bovespa, that I want to choose to predict the exchange rate. And let me leave it here. Training gonna take about 30, 40 minutes, and you can get back to our presentation, right? Let's leave them to work. Back to the presentation here. We can mention that it's very usual to process structured data. So the data that you have within database, CRMs, ERP, and so on, or for instance, those information, those data that we just query from the stock market of exchange rate and Bovespa points is structured data. You have exact information, exact columns, dates, and it's easy to cross-validate all of them. But most of the data are in fact unstructured. We're talking about videos, text, emails, image. So machine learning, artificial intelligence, it's also useful to process and analyze this kind of data. So here, one of the techniques within machine learning and artificial intelligence are neural networks. And today we talk about deep neural networks. A neural network, you have layers of processing units that can use it to analyze, especially image, videos, and some other kinds of classification. It normally do a classification. So here, for instance, you want to process that image, you want to classify if it's either a dog or a cat. There is an animal here that's hard to separate if it's an animal or a piece of cloth, but it's an animal, and the artificial intelligence recognizes it as a dog. I can see really if it's a dog or a cat or even a piece of cloth, but the neural network here recognizes it as a dog. So the process is this. We have to consolidate a large amount of data, then train models, and as I mentioned, this process here to collect, organize, and structure that database and data lakes and whatever name you want to call it, it's the hardest part. It's estimated to take about 70% of the hard work. Then we have to use artificial intelligence models and mechanisms and algorithms to train and create a model that represents or can interpret that data, and then use that model to try to predict and do analysis or classifications for new information, right? So I just trained it for historic information, or started training for historic information for Brazilian stock exchange, stock market, and the Brazilian currency against US dollar for last 5 years, from 2015 up to 2019. And then I can try to feed with new data, new values for the stock exchange, and try to predict where the exchange rate is going. That's the main idea of artificial intelligence, right? Within Google products, you can see a bunch of heavy use of artificial intelligence. So for instance, within Gmail, you have the auto-completion feature based on your own experience. So if you are used to, depending on kind of mail, reply in a similar way, Google's already suggests what kind of reply you are doing, and they'll simply confirm that you don't have to type everything. If you recognize that you're gonna say, oh, good afternoon, please see enclosed the proposal that I'm sending here, blah, blah. You're gonna predict and present that alternative to you. If you concur, you simply hit enter and you use that information. Or not only your experience, but worldwide experience. So in general, if any user replies to, I don't know, to invite for a class, or you are late to delivering a paper in a class, normally students, whatever, replies in the same manner. Oh, I would like to use an extra due date or an extension of the due date. You're probably going to present this alternative. If you agree with that option, you simply hit enter, it's going to use that text to you, right? On Google Photos, also very strong use of artificial intelligence. So you can query based on information within your photos. So here you can query for dogs, and the image is going to filter it for the image that contains a dog. I use it, it's very interesting way. When I do any payment within my internet bank on my phone, and I have the payment receipt, I keep them in photos, and afterwards, if I need to send the receipt to the vendor or whatever, I simply query the name of the vendor and shows the receipt of it. It's very easy to use. Google Search, of course, which is the main product that start all the things that are talking here. And you think about search, there is two main phases of search. The first phase, which is indexing. So Google has to navigate throughout all the sites within the internet and try to do a summary or indexing of that site. So have a website with recipes or cake recipes or whatever, a bunch of those sites. Have to index, have it registered on their own database. And once customers query the Google search for cake recipe or whatever, you have to cross-reference what information it has on his own database based on the navigation, on the indexing process that they did, with the information that the customer is asking to bring. And the order that this information is it's brought, it's also customized for each user. So the order is very important. The main site, the site that comes in the top of the page is probably going to be most used to the user, and the second one, and so on. The second page is probably going to have results that won't be very useful. And again, this ranking strategy, it's very intelligent. It's based on artificial intelligence. It's based actually on a deep neural network, which is mentioned by Google, comprised by hundreds and hundreds of layers to be able to do that. For instance, to have an idea, as these results is user-centered. So if I'm based from New York and I search for Giants, I'm gonna bring results for New York Giants. If I'm based in California, San Francisco, and I search for Giants, it's gonna present me mainly results from San Francisco Giants. So it's very user-centered, that ranking and that customization. Translation also is very interesting. So first of all, when you put a paragraph, a text, or a sentence here, you can simply let Google auto-detect what language you're using and then decide to which language you want to translate. And the translation process, it's improved, which is something very useful in machine learning. So once you have trained the model goes live and keep getting improved with new information, new feedbacks. So once he translated it to Italian here, you can send a feedback. So that's not a good translator. Let me let me give you extra information. If as many users put their feedback, their inputs, the translation mechanism gets better. It's also possible to do translation based on image, which is very useful in traveling, while you're traveling. So for instance, you have a sign here as exit. It can translate for different languages. For instance, in Portuguese here, which is saída for exit. A bunch of Google customers also use those products. So Airbnb, for instance, most of its IT infrastructure is outsourced within Google Cloud Platform. But not only that, within their products, they have embedded or integrated the Google APIs for translation. So they don't provide their website in hundreds of languages. They mainly produce in English, and it's automatically translated to the user within each country that they operate. This is a retail service, Utrentric, if I'm not mistaken, from UK. They have as many different vendors or retailers or in different services within the internet. They have a feedback or a customer satisfaction query or quiz for their customers. When you have a quantitative feedback, it's easy. So the customer provides a grade here. It's easier to manipulate and do average or calculations. Different calculations is easier. But when they provide, the customer provide qualitative feedback, it's harder to process that. Normally it involves persons manually reading those feedbacks and trying to organize or prioritize the main feedback that I want to work for. Use natural language processing API, they can do what we call sentiment analysis. So they can classify what kind of complaint or feedback it's related to, and if it's a positive or a negative feedback. So here, each color, it's a category of feedback. So in the right side is a positive feedback, and left side, it's a negative feedback. And the size of the bubbles, it's the amount of feedback that they got from that topic. So the two main positive feedbacks are billing and usability. So customers say, oh, your process in terms of payment, it's easier to pay, and mainly it's a product that you like to use, it's easy to use. But on the other hand, our main problem is related to pricing. It's considered probably an expensive product. And then at some level, they have problems using the product. So it saves a lot of energy and a lot of time if you have to process. Imagine for instance, I don't know, Amazon, if you have, imagine how many sales Amazon do and how many users give feedback, and consider if a human or a large number of humans have to analyze all the feedbacks from the customers, it would be unfeasible to process it within a sensible time frame. So probably they use something similar to this also. In terms of image recognition, they have this case here, which is very interesting. So they have satellite photos, and the satellite photos should be processed and analyzed to try to differentiate which is snow over the top of the mountains and which are clouds. And of course, there is two different decision points here. If you want, is one thing or another. So the satellite image recognizes something as snow. If you are an airplane, the pilot is a one airplane. He should be up to the altitude, which is above of course the mountains. If it's a cloud, he could calculate depending on the cloud, if you go through the cloud or avoid somehow a turbulence going through the cloud. Regardless, the error rate that they had manually analyzed those images was about 11%, and it dropped to 3% with automated recognition of images. That's, for me, it's an impressive case. Here, I could differentiate at all whatever is snow, whatever cloud here by eye. For me, it's simply impossible. Another process involving image analysis is very interesting. It's from a country called Kiribati. I never heard about it. It's in South Asia. They try to recognize pattern of ships navigate through their waters, and they recognize the pattern of a fishing boat. So a tourism boat or traveling boat, they probably work in a single line or whatever. I don't know the pattern, but somehow the fishing boat have a different pattern. Probably they travel to a point, spend a few minutes fish on that area, they move to another and repeat the process and so on. I'm not sure what the process is, but regardless, the machine learning recognized that pattern, and their government were able to issue more fines related to illegal fishing, and that led to a 2.2 million in fine increase. Of course, 2.2 million, it's a significant amount, but depending on the scale that you're looking, could be not much at all. But to the reference to that country in particular, that corresponds to about 1% of their GDP. So it's definitely significant to that country in particular. So we could use machine learning in different areas, from manufacturing, retail, healthcare, travel, financial sector, energy. I probably could say any segment, any industry is possible to use it. It would be hard to mention a segment on an industry that wouldn't apply, wouldn't benefit of it. The challenge are, first of all, try to get a grasp of the data source, the information, and consolidate and organize it. It's definitely a challenge. So try to grab information, organize, explore. That's a challenge. Then a third challenge is going to be to create, test, and validate those models. Then you have the challenge to deploy those models in production. Because let's say that you're a financial institution and now we created the artificial intelligence model that can analyze credit risk. Doesn't make any sense to have that model, but won't be able to put under production so it can process new requests for credits within the production regular workflow, right? So I have to create a model, train, have it ready to use, deploy into production so new credits requests can go through automatically that model analysis. Then once you have it production, manage, keep evolving, have a whole monitoring system and auto feed system so the model can keep growing. And lastly, be able to scale up. So if your model is currently being used for a small set of users, they start growing and becoming user for a larger number of users, probably IT infrastructure that support that model should be increasingly transparently, which is something quite usual for cloud infrastructure. And then I want to mention about the main library that Google developed in terms of creating models from the scratch, which is TensorFlow. So we have three pillars here. We can use ready-to-use APIs, for instance, vision API, translation API, speech API, natural language processing that I mentioned. That's ready-to-use APIs that can simply integrate with our application. So I want to develop an application that want to recognize image, no problem. I simply use the visual recognition API, integrate with my application, and that's it. On the other extreme, if I want to have to create my whole model from the scratch, which you are gonna do on one of the demos here, you can use a TensorFlow, which is a library developed by Google, and now it's open source, so it's possible to use TensorFlow within Google Platform, in any vendor cloud, or even your own machine, doesn't matter. It's an open source library. And in between, there is AutoML, which is the second demo that we are going to do. Actually, it's the one that you just started. So we simply, they have pre-trained model or a bunch of different models that were pre-trained and select on the best one that have the best results to return it for us. So it's something between. You don't have to program the model on your own, but you can train your own models based on your data. So we have two demos, one that's going to build the model from scratch, and the one that we just started, that you fed the data, and let's see what kind of model Google gonna return for us. And the last demo is gonna be simply to use BigQuery to see how it works. Let's take that moment and start also the other lab. Doesn't take so long as the first one, but we're gonna create what they call data lab, which is something, if you're familiar with Jupyter notebooks, or even open on Google Drive and G Suite, what they call collaboratory, which is a document, something like a document that you work collaborative, but not only for text. You can put text, but also programming and processing, either for any kind of processing, but especially for artificial intelligence and machine learning. that kind of technology is being very used by the academy and the industry. The academical world is using very heavily and liking very much to have in a single central piece where you can put information, write information, and also have experiments and have it and be able to collaborate and work with different persons online in a single element, right? So let's start this environment. Going back to the Google Cloud, I'm gonna open here the Cloud Shell, which is the command line interface. Let me open a different tab. So the command line interface, which gonna issue commands. Right. So we're gonna create data lab called, I don't know, machine learn, artificial intelligence lab. Right, so we are using Central Zone, if not mistaken, US Central A, number 8. So we're gonna take a lot of 5 minutes or so. In between, we can go to the simpler demo for the BigQuery. I guess it's going, and you can go back. Yeah, so yeah, it's finished the creation. So it was waiting for port 8081. It's gonna take, I don't know, a couple minutes. Anyhow, we can move forward here. So again, we have three different scenarios, either pre-trained APIs or models, auto-trained models, which are gonna be the second one of the demos, and the models that are gonna create it from the scratch, right, using TensorFlow. The pre-trained APIs are the ones that I mentioned: Visual API, natural processing language, translation, image recognition, so on. TensorFlow is that library that I mentioned that Google's put as an open source features. Not only the library, but they develop processing units that are specialized on processing models. As you have regular computers or servers with CPUs, when you're talking about graphical processing for video cards or video boards, you have what called graphical GPUs. And for processing models within TensorFlow, Google's provide what they call TPUs, or TensorFlow processing units. So hardware that is specialized in terms of processing models more fastly, right? Here is the pipeline of the process that's very usual in terms of machine learning and data science in general, and the different products that involved on each step. So the first step is ingest data, so to capture external data. To which you can use, for instance, Cloud PubSub or simply external files. PubSub, it's a queue that receive files from different stack and then can be processed asynchronously. Then you have the data processing pipeline, which could be Dataproc, which is based on another open source technology from Google, which is Hadoop. And then they have Dataflow, which is very similar. The difference is called a managed service. You don't have actually, as an admin or manager of that service, you don't have actually to create particular servers, or what they call nodes, in different configuration. Most of that work is doing within automatically by GCP for you. Then you can store that information that captured from the external world within different databases. Could be a regular SQL database, or an object-related database, a NoSQL database, or column-based database, also a NoSQL database called Big Table, or simply store it as an object, as a single file, as you use it on cloud storage, that CSV, that spreadsheet that generated for US dollar and Bovespa, we store it on it. Then have to analyze the data, explore the data, and try to draw intelligence and draw conclusions. In that sense, you can use Data Lab, which I mentioned is that notebook that you can do notations and programming. That's one of the demos that we're going to use. Another demo we're going to use BigQuery to query information within SQL similar databases. Also Dataproc to do analysis, or Analytics 360 to analyze website access and other information related to your e-commerce or your sites. The analysis itself are more or less the same tools, mainly BigQuery and probably a little bit about Dataproc. And finally, if you want to have create a model, not only analyze data, but to have to create a model to be able to try to predict new information within that based on previous data that you have, we could use machine learning engine. So in which you create a model, then deploy the model on the engine, or use, as we mentioned, the pre-trained APIs, right? So it's a complete process. You have it step by step. The ingestion can use batch files or Cloud Pub Sub with the queries. Then you process information, Dataproc. Then there's different database that the Google have. Then analyze the data either to Data Labs or BigQuery that we're going to use both here in the demo. And finally, have the model deployed into production, right? Again, a summary of that whole complete process involving different products. That's maybe a summarized view, demonstrate the reference architecture in which, as I mentioned, we can consume data, for instance, for IoT equipment or any other source of element that's going to push new information to a queue, and the queue going to be processed afterwards. Or if you have a whole set of external file, a batch file with different information, can be storage, for instance, to cloud storage, and then both of them simultaneously be processed by a Dataflow or Dataproc, or either Dataflow or Dataproc, and then have it recorded in a BigQuery database or a Bigtable database, or even a cloud object database. And then you have that, you can create your model based on those data, regardless of the database that you're using, and then have the visual of it either on a Data Lab notebook or external product like Data Studio from Google, or Tableau from Tableau, Kelly View for a different vendor, or so on. The AutoML, the first demo that we just started, they follow exactly the same process. They collect data, analyze, train the model, evaluate the result that the model provide, and then deploy it in production. The difference here is all that process is done automatically by Google. Okay, simply as we are doing, we can feed information and gonna create different models, evaluate the best one, and present that as to us. If we concur with the evaluation, we can deploy it to production, can use it, right? AutoML try to find the best model, trying to find the model that maximize the performance, and he tried to avoid what called here local maximums. He tried to find the global maximum in terms of performance, varying what you call, every single model have what you call hyperparameters. Hyperparameters, for instance, in a neural network is how many layers do on a neural network. For each layer, how many nodes do you want to process that set of images. So depending how you configure the network, the result's going to be completely different. If you're doing a model from the scratch, you have manually to decide for each experiment they're doing, the architecture of the neural network, how many layers, how many nodes, and so on. If you're doing by AutoML, you're going to try different scenarios in terms of neural network automatically, trying to find the best network that give you the maximum results, the global maximum in terms of performance, right? So finally, let's go to the demos. I hope that two longer one, we are ready to use it, but before you use those, let's start with BigQueries, right? So I'm gonna use BigQuery just to have an idea how BigQuery works. Keep in mind that BigQuery is a data warehouse database, it's not a transactional database. It's to have to consolidate the data of your transactional database, and then you can query it very happily with very good performance to have consolidated information. Then you're going to use Cloud Data Lab to create a model from scratch using that same data, trying to correlate Brazilian exchange rate for US dollar and the stock exchange market here in Brazil. And lastly, you're going to use AutoML tables to see what kind of model Google's generate, if it's better than the one that you build on their own or not, right? Let's do those. So let's start with the easier one. Let's start with BigQuery, right? So here, in terms of big data, we have BigQuery. And within BigQuery, I have this project here. And within that project, I'm going to create a data set and space. Let's call, I don't know, above and USD. Right? And within that data set, let's create a new table. Create a new table. That's a table based on the data that you have in cloud storage. Let's find it. That's the one here. Our codes for stock market. Let's call this table, I don't know, above USD, Brazilian real. And let have him or it try to identify automatically the schema, so the structure of the table, which is easier, two columns with numbers. But anyhow, regardless, or better than me saying those parameters, Google gonna look at the table, the spreadsheet, and find out the structure they'll have to create in order to store that spreadsheet as a table, right? So I already have the table here. I can ask to do a query. If you ever seen a SQL query, it's exactly like this. It select the name of columns, or if you want all columns, and the DBAs hate you that, to use asterisk, so you can ask for all columns, but don't have as much data as nothing big. So you can select any columns from the table that you like, and here it's a let's set with a limit. Let's quit that limit, here, drop that limit. So here it is, you can query. You have about over, I don't know, 1,000 records, a little bit more than that. And again, you probably won't see the main difference consider only 1,000 of records. If you have 100,000 billions and millions, you're gonna see the main difference in terms of performance, how performatic BigQuery is. But anyhow, on that example that you're using here, querying over 1,000 records, it took only 0.4 seconds to process, and it processed about 2 kilobytes of data. And the way that BigQuery charge of usage is exactly this. It's the amount of data that you query to process information, right? It's, of course, for this example here, it's gonna be insignificant, maybe cents. But anyhow, have all the records that you had on your table with probably over 1,000 of, the exact number is this, 1,231 records that you have. So we create all that data in only less than half of a second, right? Again, BigQuery, from the distance, from what I see here, looks like something very simple and even not different at all from SQL, but internally in the performance that you bring when you have a large amount of data, it's completely different, right? Let's do the two other demos, and I guess we're gonna pass about 5 minutes over our predicted time, but I hope you can keep up with us. So let's see, the AutoML is still running. Let's move to our model from the scratch. So we have our data lab up and running in port 8081. Let's access that, that environment. So port 8081. And the data lab, as I mentioned, you can create what they call notebooks, which is a document that you can register information and also code, mainly encoded on Python. So let's create a new notebook here. So here it's you can do code in Python, for instance. So let's print hello world in Python and hit run. Behind this document, actually, there is a virtual machine. It's also a cloud product. The first time that you hit play or read, compile, or run, it takes a little longer because it's actually creating this new machine, this new instance. And after that, it's much faster the next processing instruction. I can hit another, I don't know, print hello. After the first one, the second one is going to be much faster. Nice. It's take longer than expected. Odd. It's taking longer than expected. Oh, much better now. So that's the usual timing, and the next execution is going to be much faster, right? So let me bring the code and I have it, the code. I'm going to won't type the code from the scratch, but let me explain that code and also get the path for that file that you loaded here. Right. So here we're going to use, as I mentioned, TensorFlow, and they're going to create a new model here, right? Use that data as a source of data. And here I'm going to define the feature column. If you don't remember, even AutoML I use the same term here. So I have two columns. One going to be the feature. I could have many columns or many information. I have only one, which is the Brazilian exchange stock exchange points, which is IBOV, right? So IBOV column is going to be what you call features, the variable that I want to use to predict the label. The label is US dollar, so I want to predict US dollar in relation to Brazilian reais based on the points that the Brazilian stock exchange closed, right? So I define the feature. I can load the file that contains the data. Here I have a little loop that's going to read the data from the spreadsheet, from the file, and have it in memory structure. Then define the function that's going to define the features and use it to train the model. So we're going to use the model with the previous information from the model to try to predict new data. So what we're going to try to predict? So I have the historic information for the last 5 years. Currently, I don't know if you remember, the Brazilian stock exchange is at 100,000 points. In the scale that you use it here, it's divided by 1,000, right? So let's try to predict if the Brazilian stock exchange go to 150,000 or 110,000 or 90,000. What's going to be the dollar exchange rate once the Brazilian stock market vary on that sense, right? And then I'm going to try to do predictions, right? and I inform the feature that used to do prediction, which is the same. It's the above information, right? And finally, last loop here, printing every single prediction that are doing for each one of those values that you mentioned here, right? Let's run it. Will take a little while, like a couple minutes to train and fire up TensorFlow. So it's already fire up at TensorFlow. It's already in training and already predicted very fast, right? Oh, I guess I have it divided by 10 here, which doesn't make sense. Here you go. So right now, and again, currently it's an odd time for every stock market in the world as a consequence of the quarantine and the pandemic. But anyhow, consider the 5 last years of operation of Bovespa in US dollars in comparison to Brazilian real. As we are 100,000 points or 110, we should be with a dollar exchange rate around 4 reais. Actually, as you saw, we are over 5 reais. But regardless, based on the historical data that have, that should be the exchange rate that you should be working with. If the exchange rate goes up very fast or very strong, up to 150,000 points, the exchange rate should also grow on that proportion, should reach 4.5 reais. So the exchange rate that are today over 5 reais, the stock market, Brazilian stock market should be probably close to 200,000 points. But anyhow, the current scenario, of course, it's very peculiar. It's not comparable to the historical data. It's also something that's usual to models. If you do a model with the 5 last years of information, you still have to feed in with new data to try to improve it with new information. Of course, the scenario, the business scenario can change, and the model have to adapt and to learn with this new information, right? So that's the result that I have building a model from the scratch. Let's see the model, auto model that was being trained. Let's see. Oh, it's finished right on time. Perfect. So it's saying here that that's an interesting metric here. It's a root mean square error. So what he's saying here roughly is that on average, the prediction that he's doing for the US dollar in comparison to Brazilian reais, it can vary, can have an error of 22 cents above or below, right? But it's more or less okay number. This R2 here should be a number close to 1. It's not that close. Again, it's only an example that you're trying to do here, but it's, I don't know, it's fair enough. Let's try to evaluate with new data, or evaluate, no, evaluate, you just saw the information. Let's try to use it. Evaluate is exactly the same information that you just saw. Root mean square error, R2, and so on. Let's try to use it. We could do online prediction. In order to do online prediction, we have to deploy the module. So we'd have to deploy the model. Anyhow, I'm not seeing the button here to deploy, but regardless, the deployment here gonna take us a lot of extra, I don't know, 5 minutes. We're not doing an online prediction and deploying the model in production. Let's do a batch prediction and using a spreadsheet again. We're gonna use the same values that you use it to do for our model from the scratch. Let's use these very same values here. 150, 110. Let's go back to our spreadsheet and create a new tab with a index here or ID and the IBOV code that you want to use. So the first one is 150. The second one is 110. The third one is 90 and the last one is 80, right? I'll name it. And the last one is 80. Let's rename it to predictions. Let's download it. Right. Let's upload it in the cloud storage. Cloud storage, cloud storage, cloud storage. Here is our bucket. Let's upload that file. Right. Right. Let's go back to our trained model and use as entry data source for new information so he can predict. Let's use a cloud storage. Let's browse to the bucket that you have our file there. That's the last one here. And the file that we just loaded is this one. Okay. And I guess that's it. Here's the deploy model that I mentioned. I can initiate it, but gonna take, I don't know, 5 minutes. I'm not gonna use it, but let's hit it anyhow. And for batch production, I don't know, should have this button here ready. Oh, and he asked where the results I wanna put it. Let's put the results in BigQuery. BigQuery. He's gonna ask about the project and here it is. So the results, the name of the project, that's the only thing that he wants. The name of the project is this one. All right, now we have it. So the source of new data that I want to use to create new predictions is the new spreadsheet that you just created, which you storage on cloud storage. And once the model is going to process the results, he's going to save it within BigQuery, right? So let's hit send batch production. He's doing his thing. And probably we're going to have here, he's going to create a new data set. Once it's finished, it's still running, right? Gonna take, I don't know, 30 more seconds or so. Guys, thanks for extending the time a little bit. Appreciate it. That's why I was concerned about time. We have tried to pack as much demo and practical information as you wanted, but it's not easy to fit all of that. And graceful, it seems that you didn't have any errors, which is not very usual. Live demos always has a risk. But anyhow, we're just finishing the last one. Couple more seconds, then we are done. So recapping, Our first demo, the smaller one, was simply a small demonstration of BigQuery, and if you didn't look very carefully, it could look like a regular SQL database, but it isn't. It's a data warehouse database with very strong performance in querying results. Is be able to query in matter of seconds, billion of records, right? Then we use a data lab, which is equivalent to, if you're familiar with Jupyter Notebook or even Google Colab, that's available within Google Drive. But data lab is a resource or a server that's embedded within GCP. So on that sense, we created a Python notebook, and we processed a whole new model from the scratch using TensorFlow. And where we were able to predict US and Brazilian real exchange rate based on the Brazilian stock market. And lastly, we spent about 40 minutes here with the auto-trained ML from Google. They create a bunch of modules and select the best one based on the data that we fed. We trained it and provided it, we just provided with new data so he can predict. He just finished. And if you are lucky enough, he registered the results within BigQuery, right? So within BigQuery here, we should have a new data set with a new table of results within that project here. I guess is this one. Yeah, this one. Let's, that have two tables, the errors and the predictions. Let's query the predictions. Or even here, have the preview, or I have the results. We can even compare with our own trained model. Let's see if it brings. Here it is. So it predicted the Brazilian stock market at 150 points, a US dollar of 5.2 reais, which is probably close to a current scenario, very different from the one that you predict manually. Then the scenario with the stock exchange at 80,000 points, we predicted manually with exchange rate of 3.6, and he's predicted a little over 44 reais. The 90,000 points, he predicted a US dollar of close to 5 reais. And the last scenario with 100,000 points, we predicted manually with close to 4 reais. It predicted at over 5 at 540, which seemed closer to reality, right? Remember the reality, currently we are very close to 100 points, 100,000 points, and the exchange rate is at 532. The automatic Google process was much better. They are own model from the scratch. It's 539. It's very close. And again, we didn't predict at 100 points. We predict 110. So probably it's very close to current reality. So it's very hard to beat the AutoML. We have to give more detailed information, more subtleties. If you have simply used the standard data and standard techniques, probably the AutoML is going to be better than you. But regardless, of course, it's all a play example, play experiment here. It's not serious at all. I hope you enjoy. I appreciate that it took a little longer with me. Let me share here my contact information. Feel free to reach me at my email regarding to this subject here, machine learning, artificial intelligence for Google Cloud or AWS, as I mentioned. Any service within the cloud, either servers, database, storage, and so on. We have a very strong service in terms of the DevOps. So the idea of having continuous delivery, continuous integration with a whole pipeline of software development can help you on that. Please feel free to reach. Thank you very much again to extending the time. That's it. Bye-bye.